This is the anomaly press briefing for the Orbiting Carbon Observatory. Here to tell us what happened during the launch this morning is Chuck DeVal, the NASA launch director from the Kennedy Space Center, John Brunchweiler, the Taurus program manager from Orbital Sciences Corporation, and we also have with us to respond to questions Michael Freilich of the NASA Earth Science Division at NASA headquarters. And we'll begin first with Chuck DeVal.
Good morning. NASA's Orbiting Carbon Observatory satellite failed to reach orbit after its 1:55 and 31-second launch time liftoff from Vandenberg Air Force Base here in California. Preliminary indications are that the fairing on the Taurus XL launch vehicle failed to separate. The fairing is a clamshell structure that encapsulates the satellite as it travels through the atmosphere. The countdown proceeded nominally towards launch. We worked the typical minor issues. We did have one issue with the flight termination system receivers and the capturing of that with the range. It wasn't a significant problem. It just occurred late, and it forced us into the second target opportunity, which was 1:55 and 30 seconds. We reached consensus and targeted the T0, and the sequence of events were we did have stage 0 ignition. The first stage on Taurus is actually called stage 0. It's Castor 120, and it ignited at 1:55:31 local time, and all indications were nominal at that point. The motor proceeded to burn for approximately 1 minute and 24 seconds, where it burnt out, and the first stage ignited. That proceeded normally and burned out at 2 minutes and 43 seconds into the flight. That separated 5 seconds later and allowed the second stage to ignite 1 second after stage 1 separation. At that point, 7 seconds after stage 2 ignition, we expected to see fairing separation. We had indications that the sequence was sent. But shortly after that, we started getting indications that the fairing did not indeed separate. And at this point, I'll turn it over to John Brunchweiler to speak to that event.
Well, first let me say that and our whole team, at a very personal level, are disappointed in the events of this morning. And it's very hard, and we are, as I said, at a very personal level, upset with the results. Now, on what we did expect, the fairing separates by a sequence of electrical pulses that drive ordnance, and the clamshell fairing is a two-piece device, and it's separated at first with 4 pulses from an electronics box, and these are 2 primary pulses and 2 redundant pulses, which separate the longitudinal, we call them the fairing rails, which is the vertical part, if you will, of the fairing. And then about 80 milliseconds later, the base joint is severed in a similar fashion, that is with 4 pulses, 2 primary and 2 redundant. As Chuck indicated, we have confirmation that the correct sequence was sent by the software. We had good power going into this event, and we also had a healthy indications of our electronics box that sent the signal. Once that time had passed, which was about 3 minutes into the flight, we had observed various pieces of telemetry that, of course, we then try to correlate, and because at first, being humans, we don't necessarily believe one piece of data, and we need to correlate the various pieces to kind of come to a conclusion, and indeed we did come to that conclusion later in the flight. Okay. The pieces of data that we saw when the fairing comes off, we actually have little wires that are looped back that as the fairing comes away, these wires break, and we have an indication that the fairing has separated. Those indications did not change. We also have temperature sensors on the fairing, and we continue to measure reasonable, realistic temperatures even after the time that we expected the fairing to come off. And probably the most significant piece of data that came later is that when the fairing has considerable weight relative to the portion of the vehicle that's flying, so when it separates off, you get a jump in acceleration. We did not have that jump in acceleration. As a direct result of carrying that extra weight, we could not make orbit, and the initial indications are is that the vehicle did not have enough delta V to reach orbit and landed just short of Antarctica in the ocean. Chuck.
A mishap investigation board is being convened to determine the cause of the launch failure. And I'm confident the integrated team will do a thorough investigation and determine the cause, and we'll get back to flying at a pace that allows us to do so successfully. George.
All right, thank you, Chuck. We're ready to take questions. Please give your name and affiliation when the microphone comes to you. We got questions here in the front? Just start here.
Nora Wallace, Santa Barbara News Press. How confident are you of the location where the satellite landed?
Fairly confident. All indications, we constantly take altitude, velocity measurements, and we've had, I think, several different predictions come to the same conclusion. We'll know more tomorrow, a more accurate location, but we're fairly certain that it did not overfly any land, and it landed just short of Antarctica.
Janine?
Was it being monitored by the P3 at that time, or what kind of tracking did you have on it at that point?
I know that we were getting telemetry, is that correct, from the P3 at the time?
We were getting P3 telemetry in real time.
Chris Stoltz, Santa Barbara Independent. Can you give us some idea of how much loss we've suffered here from the space program, both monetary and in terms of time?
I think the total mission, I'm not sure of. I think it was, I'm not sure if I'm the best one to answer that.
We can probably get that information for you. I guess we just don't have it at our fingertips here.
But, you know, certainly for the science community, it's a huge disappointment. As you've heard from this morning, the anticipation of this groundbreaking spacecraft to measure what is in the forefront, you know, of every newspaper. It's taken so long to get here.
Michael, do you want to add anything to that?
Sure. As was said, OCO was an important a mission to measure critical elements of the carbon cycle. And over the next several days, weeks, and months, we're going to carefully evaluate how to move forward and advance that science, given our evaluation of the assets that are on orbit now, the assets from our international partners, and the existence of flight spares and everything, in order to thoughtfully put together a program to, as rapidly as possible, pick up where OCO left off and advance Earth system science.
Any further questions here? Question in the back.
Ty Adranis with California Academy of Sciences. Were there any hazardous materials on board, and if so, what environmental repercussions can we expect to see?
Good question. I know that there was hydrazine aboard the spacecraft, and I'm not certain of the results of that. All indications from the launch vehicles that all stages did burn. So there's only, from the launch vehicle side, there's only, there's not much.
All right, we have some follow-ups here. We'll start with Janine and go to the left here.
Was there anything new about this fairing or anything new involving Taurus and that could have led to this problem?
No, we have flown this fairing before.
Nora?
Any repercussions for the Glory mission, or is it too early to tell at this point?
I think it's probably too early to tell at this point.
There did seem to be some kind of power glitch before ignition. Could there be any connection?
Currently, that was on a separate system, so I don't believe at this time that there's any connection.
Okay, we're going to go now to NASA headquarters and take some questions from up there. I believe Seth Bornstein from Associated Press is first.
Yes, thank you for taking this. If I can ask a two-pronged question, one for John and one from Michael. For John, you said you've flown this fairing before with no problem. I know, what was it, 7 out of 8 or 6 out of 7 successes before this for Taurus. Have you had any indication in any of your past flights, not just Taurus, but any of your vehicles, of any problems with the fairing set before, or even in test flights? And for Michael, as you noted, there's flight spares. Can you give us a quick rundown on what do you have on the ground in terms of flight spares and what do you need?
Okay, the first part of the question, this is John Brunschweiler. In the past 10 years, we've flown a nearly perfect record, 56 out of 57 vehicles, and we have not had any issues with this fairing design in the past.
And regarding the question on flight spares, at this time we don't have, I don't know, I should say, a complete inventory of the flight spares or what we would need should we make the decision to rebuild an OCO.
And Seth has a follow-up, I think.
Okay, so yeah, just to follow up on John, I know you haven't had with this fairing design. I guess maybe my question was I wasn't clear enough. Have you had any problems with any of your fairing designs in the past? Thank you.
Not that I know of. Like I said, we have a pretty robust record, so I'm not aware of any.
All right, we have another question from headquarters. I believe Tariq Malik from Space.com.
Hello, this is Tariq Malik from Space.com and thank you very much for taking our call. My question, I have one and a follow-up. The first one is, I guess, a repeat regarding the flight box for the Glory mission. The audio kind of cut out earlier on your answer. I was just curious what, maybe for Mike or for Chuck, what do you need to see from this mishap investigation that would give you confidence to keep a Taurus XL for Glory later this year?
Well, I think what we need to do is come to a most probable cause for this failure, and we'll let the board, when it forms, run through its rigorous process and outbrief. We hope to have a most probable cause. Sometimes when you conduct boards, you get most likely, but our goal will be to find a root cause for the problem, and we won't fly Glory until we have that data known to us.
All right, we have a question from Irene Kloth from Reuters.
Yes.
Can you hear me all right? I'm sorry, can you hear me?
We can hear you.
Yes.
Hello?
Yes, we can hear you.
All right, well, I guess we'll go ahead to any other questions they would like to answer. Any follow-ups here in the room? We're going to come back here to Vandenberg.
Timeline for the length of the investigation?
No, I can tell you that within the next 24 hours we'll name a chairman, and shortly after that, board members will form. So we probably should let them, at that point, drive the schedule and the process.
Right here in the end.
Michael, you said the OCO might not fly again. This might be the last one.
I did not say that.
You indicated that it might possibly be the last one.
No. We are committed to advancing Earth system science in NASA, which involves measurements of many different variables in order to understand the processes which define the Earth as an integrated system. OCO was to make some important measurements of the carbon cycle related to the carbon cycle of carbon dioxide in the atmosphere and pathways between the atmosphere, the oceans, and the biosphere. There are other measurements which are related and other measurements which are complementary. What we're going to do is take a good, solid, and thoughtful look at how best to advance Earth system science in general, and with a focus on the carbon cycle as well. Given all the assets that we have available now and into the near future, and decide how it is best scientifically as well as for the nation to move forward.
Shadeen?
Can you say it at all right now whether the nose cone partially came off? None of it came off? Do you have any kind of indication?
The initial indications is that it did not come off, even partially. But again, we haven't even started the investigation yet. We're just able to report what we observed.
All right, we'll go back to headquarters and try again for another question or two, and then we'll come back here. Okay, we're going to come back here and take another couple of questions, and then we'll conclude. Right down here at the end.
Tyadronis, California Academy of Sciences again. Any idea in years how far this has set back the program to observe Earth?
That's an excellent question. I can tell you that it has been nearly 8 years, excuse me, to develop OCO. To this point, many scientists and engineers are really devoting, throwing themselves into this endeavor. By the same token, in January, our international partners, the Japanese Space Agency, launched a satellite that makes complementary measurements of carbon dioxide in the atmosphere, called GOSAT. Over that period of time, algorithms have been developed for other instruments that are presently on orbit that lend some information on carbon dioxide in the atmosphere. So the science is advancing, our understanding is moving forward, and it is difficult at this time to put a precise time delay, if you will, on how quickly in the future we'll be able to realize the understanding that OCO would have given us had it succeeded.
And we'll take one last question here on the end.
Can you give us some picture of the emotions when this happened, any colorful language, that sort of thing?
Well, hope comes to mind. I mean, I think the team was looking at a variety of different screens, whether it be infrared cameras or telemetry, and at different times the indications were coming to them in different ways. So how they interpret it was probably at different speeds, and hopefully, in some cases, a clear-cut indication to them that there was trouble, where others maybe had some hope that it was just a telemetry indication and that the vehicle was in fact fine. So it was probably a variety of different things, but the one thing that's constant is a huge disappointment to the entire team that's worked very hard over years and years and really did their best to see it through. And the reason not everyone is able to do this is it's hard, and even when you do the best you can still fail. So it's a tough business.
Right, and headquarters would like to make one last attempt here on getting another question through, so we'll try again at headquarters. All right, we're not going to be able to make contact again with headquarters, so in that event, then that is going to conclude our briefing. Thank you.
You're watching NASA Television, awarded an Emmy for Lifetime Achievement by the Mid-South chapter of the National Academy of Television Arts and Sciences.
It's a challenge because it's one of those things that's hard. It's hard to explain if you haven't been there. But the main things are the view. I mean, the view of the Earth from space is just astounding and amazing. It's more beautiful than the highest mountaintop view I've ever seen. But you're up in the space environment where everything above you is blackness, and you can see the Earth below you in the atmosphere, and it looks so beautiful and green and blue. I think the moment that stood out for me was my first real look at the Earth on my first mission. You launch and you're very busy for 8 to 10 minutes as the engines are going and getting you safely into orbit, and then you're still quite busy for the next whole orbit basically as you get the orbiter changed around from being a rocket on launch to being an orbital vehicle. We're busy in the front, we've got our suits on, it's kind of uncomfortable, and then there was a moment about an hour into the flight where I happened to look out to my right, out my right window, and I looked down and we were over the Pacific and there was Hawaii right below us, and it looked just huge. We were only about maybe 90 miles up at that point, which seems like a long way up, but the Earth looks pretty big from there. And I just saw the beautiful Hawaiian Islands passing underneath as we went over at 5 miles a second, and that was just an amazing sight. That really burned into my memory from my first mission. It varies very much from one person to the next. For me, it was about a day. You spend your whole life down here at 1G, and then you're thrown into this 0G microgravity where you're just floating and everything's floating. It takes a while for your body to get used to that, but after about a day, you're kind of back to normal, and you can do your work for the rest of the mission. And it's the same in reverse when you come home. You've spent almost 2 weeks up in 0G, and you come back on entry and into land, and it takes your body a couple days to kind of get used to being back down here in this this 1G environment. But that's about all. After that, you're back to normal. It's a very different experience. I mean, the shuttle's coming in as a glider, so we're very interested after we do our deorbit burn on the other side of the world, basically, of tracking our progress very carefully across the Pacific and then across Mexico and the Caribbean as we come into the Kennedy Space Center. And then once you get close to the Kennedy Space Center, coming in on that steep dive, lining up with the runway and getting it touchdown much faster than an airliner or even a tactical jet would touch down. We've spent a lot of time practicing, a lot of practice approaches. All have well over 1,000 by the time we get to do it for real. So it's an interesting task, but we get a lot of practice for it. Probably all of the folks that are currently astronauts, you know, we didn't think we were going to be astronauts when we grew up. We just decided to do something that we really loved and were really interested in. And we went down a path that eventually we found out, hey, I could apply to NASA with this resume. So we did, and then we were very lucky to be picked. So if someone's interested in space flight, and I hope most people are because it's an amazing experience, the best way to get there is to do what you're really interested in, do what you love, and that'll give you the motivation to really do well and to excel. And that's really what NASA's looking for. We'd love to have folks that are great at what they're interested in, what they do, and we can make use of that.